Welcome to Cosmic Compass, the channel where we navigate the wonders of the universe, one celestial story at a time. From the birth of stars to the death of planets, from black holes to distant moons, we go beyond headlines and dive deep into the science behind the cosmos. If you're ready to explore, let's begin. From afar, Venus appears serene, like a soft glowing pearl drifting through the solar system. Its pale yellow hue and graceful glow have earned it a romantic reputation, named after the Roman goddess of love and beauty. But if we dare to look beneath its clouds, that illusion quickly vanishes. What lies underneath is a world of extremes, a hostile landscape of crushing pressure, volcanic plains, and an atmosphere thick with toxic gases. Venus is beautiful, yes, but it is also the most hellish place in the inner solar system. Today, let's peel back the layers of this enigmatic planet. Together, we'll explore its orbit, rotation, atmosphere, surface, and the strange ways it behaves. By the end of this journey, you'll understand why Venus is one of the most fascinating and misunderstood planets in our cosmic neighborhood. Venus is the second planet from the Sun, positioned between Mercury and Earth. On average, it orbits at about 108 million kilometers from the Sun, roughly 0.72 astronomical units. Unlike most other planets, Venus travels in an almost perfect circle. Its orbit has the lowest eccentricity of any planet, which means its distance from the Sun barely changes throughout the year. When Venus is at its closest to Earth, about 41 million kilometers, it becomes our nearest planetary neighbor. But interestingly, that's not when it appears brightest in our sky. Why? Because when Venus is closest, it lies between Earth and the Sun, showing us mostly its night side. Instead, it shines brightest when it's a thin crescent just off to the side of the Sun in the sky. During these times, it becomes the third brightest object in the sky, after the Sun and Moon. This intense brightness has caused plenty of confusion. Many people, including US President Jimmy Carter, have reported seeing unidentified flying objects that later turned out to be Venus. Have you ever mistaken a planet for something more mysterious? Since Venus lies between us and the Sun, you might wonder, does it ever pass directly across the Sun's face like an eclipse? Yes, it does, but not often. This event is called a transit, and it's one of the rarest predictable astronomical phenomena. Transits of Venus occur in pairs 8 years apart, but each pair is separated by over a century. The last time it happened was in 2012. Before that, it was 2004. If you missed both, you'll have to wait until 2117 for the next one. Why so rare? Because Venus's orbit is tilted slightly compared to Earth's, so it usually passes above or below the Sun from our point of view. When it does align just right, the sight is unforgettable. A tiny black dot slowly drifting across the brilliant solar disk, a subtle, delicate dance between two worlds. In most ways, Venus plays by the same rules as the other planets. It orbits the Sun in a counterclockwise direction. But its rotation breaks all expectations. Venus spins backward. Unlike Earth and most other planets, Venus rotates clockwise on its axis, a motion called retrograde rotation. And not only that, it rotates extremely slowly. One full spin takes 243 Earth days, making it the slowest spinning planet in the solar system. What's more bizarre is that a year on Venus, the time it takes to orbit the Sun, is shorter than its day. A Venusian year lasts 224 Earth days, but due to its retrograde spin, the time between two sunrises a solar day is only about 117 Earth days. 17. This means you'd experience less than 2 full sunrises and sunsets in an entire Venusian year. At the equator, the planet spins at just 6.5 kilometers per hour. That's walking speed. Why does Venus rotate this way? No one knows for sure. Some theories suggest a colossal ancient collision Others propose tidal interactions with the Sun or its dense atmosphere. Whatever the cause, it's a cosmic oddity. Venus is often called Earth's sister planet, and at first it seems fitting. It's nearly the same size, just a bit smaller, at about 1,100 kilometres in diameter. Its density and internal composition are also very similar to Earth's. Gravity on Venus is 90% that of Earth. You'd barely notice the difference walking there. Both are rocky terrestrial planets formed from similar materials in the early solar system, but that's where the similarities end, because while Earth is teeming with life and water, Venus is dry, scorching and suffocating. Something happened in Venus's history that sent it down a very different path. Let's find out what that was. The atmosphere of Venus is, in a word, brutal. At the surface, the pressure is 92 times greater than Earth's equivalent to being 1 kilometre underwater. That's enough to crush most spacecraft in seconds. The air is thick, with carbon dioxide making up over 96% of the atmosphere, along with clouds of sulfur dioxide and sulfuric acid. These gases create the strongest greenhouse effect in the solar system. Sunlight enters, but very little escapes. As a result, the average surface temperature is 462 degrees Celsius, hot enough to melt lead, and this heat doesn't go away. Day or night, pole or equator, the temperature remains nearly constant. Venus acts like a thermal flask, trapping heat with deadly efficiency. Even though Mercury is closer to the Sun, Venus is far hotter because Mercury has no atmosphere, while Venus has one that acts like a lid on a pressure cooker. The sky here is a choking, toxic soup. You wouldn't last seconds standing on the surface, and yet for scientists, it's one of the most compelling places in the solar system to study. Why? Because it shows us what a runaway greenhouse effect can do, an invaluable cautionary tale for our own planet. Despite the stillness on the surface, the atmosphere above Venus is full of motion. At ground level, winds are sluggish, just a few kilometres per hour, but because of the extreme pressure, even slow-moving air packs tremendous force, capable of shifting rocks and dust. Higher up, things get much more violent. At the cloud tops, winds reach speeds of up to 300 km/h. These upper clouds race around the planet in just 4 to 5 Earth days, far faster than the surface rotates. The clouds themselves are thick and bright, reflecting nearly 90% of sunlight. Made primarily of sulfuric acid droplets, they obscure the surface from space and give Venus its characteristic glow. Occasionally these clouds produce lightning similar to Earth storms, but far less frequent. One particularly fascinating discovery is the giant vortex at Venus's south pole, a swirling storm structure similar to Saturn's polar vortices. Suspended about 59 kilometres above the surface, it adds yet another layer of complexity to Venus's already bizarre atmosphere. Venus doesn't just cook, it churns. Strangely enough, there's a region in Venus's atmosphere that's almost Earth-like. About 50 kilometres above the surface, the temperature is mild, the pressure is similar to sea level, and the gravity is close to what we feel on Earth. Sounds inviting, right? Well, almost. The catch is the air. It's still full of CO2 and sulfuric acid. You couldn't breathe it. But theoretically, in a sealed habitat or floating platform, humans could survive here far more easily than on the surface. Some scientists have even proposed airships or sky stations hovering in this habitable layer. Imagine living in the clouds of Venus, gliding above the burning ground in skies of gold and acid. It's not science fiction. Not entirely. No planet has destroyed more spacecraft than Venus. But in the 1960s through 1980s, the Soviet Union made history with the Venera program, a series of bold attempts to reach and survive the surface. Venera 7 in 1970 became the first spacecraft to land on another planet and transmit data back. It only lasted 23 minutes, but that was enough to confirm surface temperatures of 425 degrees Celsius. Venera 9 sent back the first images from the surface of Venus, revealing a rocky, desolate landscape, bathed in a pale orange light. Later missions Venera 10, 13 and 14 delivered colour photos, seismic readings and chemical analyses. No other probes since have landed on the surface successfully. The conditions are simply too extreme. But orbiters and radar mapping missions have continued the work building a detailed image of Venus's surface from above. It's not just a scorched wasteland, it's also geologically fascinating. Venus is a volcanic world. Its surface is covered in ancient lava plains and dotted with over 1,600 major volcanoes, some over 100 kilometres wide. That's more than any other planet, but Venus's crust is different. Earth has tectonic plates that constantly recycle the crust over millions of years. Venus doesn't. Its surface is static and old. Estimates suggest a global resurfacing event occurred 300 to 600 million years ago when internal heat built up beneath the crust and erupted, covering most of the planet in lava. Today, Venus shows signs of volcanic structures, but it's unclear if any are still active. What we do know is that over 80% of its surface is volcanic in origin. There are also over 900 impact craters, but none smaller than 3 kilometres. Why? Because the dense atmosphere burns up smaller objects before they can reach the ground. Venus preserves only the scars of the largest cosmic collisions. Given its similar size and structure to Earth, you'd expect Venus to have a magnetic field, but it doesn't. This absence puzzled scientists. Without a magnetic shield, Venus's upper atmosphere is constantly bombarded by solar wind and cosmic radiation. This interaction generates an induced magnetosphere, but it's weak and unstable. Over time, this solar stripping has created a long tail of ionized particles stretching away from the planet, much like a comet. Sometimes, when Earth and Venus align just right, this tail can extend far enough to brush against our own magnetic field. Invisible, silent, but it's there. Venus is a planet of extremes, equal parts mystery and warning. From its molten surface and choked atmosphere to its ghostly winds and backward spin, it challenges everything we expect from a terrestrial planet. It could have been Earth's twin, but instead it became something else entirely. Perhaps by studying Venus, we're also learning about Earth, about the fragility of climate, the power of greenhouse effects, and the thin line between habitability and hell. Thanks for joining us on this journey. If you enjoyed exploring Venus, there's a whole solar system waiting to be discovered right here on Cosmic Compass. Let's keep exploring together. Thanks for travelling with us through the clouds of Venus. If this journey sparked your curiosity, there's a whole universe waiting to be explored. Make sure to subscribe to Cosmic Compass for more deep space storytelling and drop a comment. What part of Venus surprised you the most? Until next time, keep your eyes on the stars and your thoughts among the planets. See you in the next voyage.